Hello, everyone, and welcome. I'm so glad to see you all here today for this special training session with Open Energy Transition as part of YouthMappers' 10-year anniversary celebration. This year, on November 17th, during Geography Awareness Week and GIS Day, we are celebrating a decade of YouthMappers. Leading up to that milestone week, YouthMappers is launching 3 anniversary mapping campaigns: Where We Live, Where We Move, and Where We Power the Future. Today's session focuses on that third campaign, Where We Power the Future, our exciting collaboration with Open Energy Transition. Together, we'll explore how open mapping can support global access to reliable and sustainable energy. By the end of this training, you'll be ready to contribute directly to the YouthMappers OET mapping campaign, helping us power the next decade of impact through open data. I'm especially excited to be joined today by Andreas Hernandez Denyer, who will guide us through why mapping power grids is so important and how you can get started, even if you've never mapped power lines before. With that, let's get started.
Yeah, just first, thank you so much for everyone for coming and wanting to map basically. And so how this is going to go, I've got basically 50 minutes more or less to teach you and make you understand why it's important to map power grid data in OpenStreetMap. So just a little bit, I'm so half Spanish, half English, but grew up in France. I have a background in environmental technology and economics. And in terms of what I do at MapYourGrid, basically a bit of everything, mostly software development, tooling, creating strategies, making videos, building the website. And so for today, basically, we're going to first start off with a 10-15 minute presentation on explaining basically our initiative, what's the problem, so what's the problem we're trying to tackle, why it's important to have open grid data, how we're trying to achieve basically this goal of having open grid data for everyone. And then we'll have a 5 minute or 10 minute period for questions on the initiative. And then we can start basically the mapping. So yeah, I'm just gonna start showing my screen. Okay. Can you see my screen?
Yes.
Okay. Right. You can see my slides, right?
Yes, we can.
Cool. Perfect. So first I'm just going to start with what's wrong. So on the left here, you can basically see projected changes in surface temperature, i.e. climate change, and basically due to greenhouse gases that we're emitting. And since 75% of, let's say, all global greenhouse gases come from burning fossil fuels, there's an urgent need to increasingly develop renewable energy and thus electrify our societies, so heating, industry, transport. But that electricity needs to be transported from where it's generated to where basically the load is, where the demand is. But on the right here, you can see there's also another major issue is that in many countries, firstly, they're just not everyone has access to electricity. So particularly in sub-Saharan Africa, which is a massive problem for socioeconomic development. And so, with the growth of renewables and electrification, how do you get large amounts of electricity from point A to point B? That's transmission grids. So, transmission grids are basically the backbone of our electricity systems, and they transport electricity large distances at high voltages to reduce losses, basically. And so basically, in order for the energy transition to even have a chance, our grids need to grow and develop, which, as you can see from the IEA, projected growth is double, triple. But in order to effectively plan and invest in the grids, we need data. And the main issue at the moment is that data of the grids is often outdated, incomplete, or closed, private. And so, in order to effectively plan for the energy transition, this transmission grid data, as well as power plant data, is needed. And so, the transmission grid data is basically used by governments, utilities, developers, researchers for planning, energy system modeling, electrification studies, also disaster and emergency responses, and to guide investment decisions. So why is there value to having open grid data, and in our case, OpenStreetMap grid data? So there's value from having grid data being open as it's usable by everyone, and in certain countries, it's also the only up-to-date public data of the grids. Um, but also it can complement and cross-validate official sources, so system operators' data, and in some cases actually be better. But there's also value from, let's say, having all of this data in one platform, for example, transmission grids cross countries as interconnectors. And so having all of this on one platform just makes it much easier for different, for example, system operators in countries to know their neighbors' grid. But also within the country, you have many large countries generally who have different operators who might not necessarily have all the data from their neighbors, let's say. So who am I talking about exactly? So it ranges really from many international organizations such as the IEA, IRENA, World Bank. Other purposes linked to, as I said, disaster relief, so Red Cross, Médecins Sans Frontières, etc. To private corporations who have this data and build software out of it, as well as academics, researchers, universities using it for different studies, energy system modeling, for example, using it for PIPESA. So there clearly is value to this data as it's being used by many of these organizations. But so the quality really varies. So let's say users around the world have been mapping power grids for maybe 15 years, more or less. But this mapping is generally done, let's say, by a few individuals or a community at certain points in time. So it's not always updated. Some countries might be really well mapped, others not so much. And so, yeah, so basically, as you can see on the screen here, this is North Vietnam. Some of those lines aren't finished. So this data quality really varies, which means that there's still a lot to do. Which is why we created the MapYourGrid initiative. So basically, our goal is to make OpenStreetMap grid data the standard of Open Grid data, and in terms of coverage, but also in terms of quality. We want it to be high quality, and this includes lines, substations, power plants, but also more technical data such as voltages, circuits, which are all tags in OpenStreetMap. And so here you can see our founding members as well as some new partners. And yeah, so the 70%, so we basically estimate that between 75% of the transmission grid in real life is mapped already in OpenStreetMap. This varies between country, but the goal is to get to that 98% to really have almost every single country, well, every country at a really high level. A few numbers first is, so we've got 49 mappers using our hashtag, hashtag MapYourGrid. As our team, we've added 220,000 towers around the world, mostly in developing countries, but basically in every single continent. Many kilometers of power lines added. But also we've got almost 50,000 towers added by people in the community who've maybe seen our videos or something, who are using our hashtag. So that's really good. But how do you want to reach this goal, and what do we do exactly? So we develop tools and also utilize existing tools. So for example, on the left, we've got an interactive world map, which you can basically click on a country and that will load the entire power grid of said country. But it also has tools inside which are pre-existing, but we just integrated it. So for example, on the right, you've got Osmose, which is a quality assurance tool, which is used for basically anything OpenStreetMap related, but we've used it for power mapping, basically. And we've also have, for example, a plugin which we've done for voltage estimator. So this really varies in terms of what we've developed. But then there's also the strategy side. So we've gained a lot of experience in the last 9, 10 months, but we have people been mapping for years. And so we developed strategies on how to map fast, effectively. And so, for example, on the left here, you've got we're using Mapillary on GeoSM to see the images of the towers, seeing how many cables it has, which tower connects with which. And there's just a bunch of different strategies that really help to map fast and find things that need to be mapped. But we also have, for example, on the right, a massive catalog of public electrical grid maps, data, reports for almost every country in the world that we could find. Um, and this is really useful just in itself to have that as a catalog, but also for mapping because it can be used as like hint layers to know where each substation is located, etc. So, so that's the mapping, but we also want the mapping that is made to be of high quality. And for that, we have validation. So this goes pre-mapping and post-mapping. In terms of pre-editing, we've got standards and guidelines on like wiki pages, for example, on how to map everything related to power. We also have like a power quality assurance validator in JOSM. So before uploading, you might have some issues there. Um, we also potentially can review edits thanks to the hashtag if you use the hashtag and help the community fix issues that they can't fix themselves. But then there's also post upload, let's say. So this is, for example, Osmose, the quality assurance tool, which is super useful for looking at the quality of the grids. But we have other developments that are potentially being made. So testing the grid data with external systems to see if it actually makes sense in real life with real world applications. And also potentially AI assisted random sampling and field validation. But that's, let's say, in the pipeline. Then training material. So very important to not keep all the knowledge ourselves, but also to give it to the community. So we have, for example, a bunch of YouTube videos which you can follow on different tools, strategies, using ID, using JOSM. We also have in English and Spanish, and soon a few other languages. And then this one, so I think it's much more fancy to do software and tooling and everything. But the I think the real value comes from the community engagement because at the end of the day, for example, our team, we can map really fast and really well, but this is only 2025, 2026. The real goal is to really build a strong community that knows how to map power infrastructure in their own country or any country, and that can do this in the very long term, so that the quality remains really high, not for just 1 year or 2 years, but for 20 years or more. And so to do this, for example, we've had training workshops with, for example, a community in Myanmar. We're in contact with different strong mappers, but also different OSM communities and groups, and hopefully you. And yeah, and much more to come. So we have, for example, working on a health score to look at, let's say, the quality of the grid for each country, videos in other languages. We're doing better monitoring of contributions, and also gamification of power mapping. So in terms of benefits to you guys, to mappers, so why should we map the power grid as an individual? So first things first is you have a direct impact yourself on important issues, as we've seen. So this data is super useful and is being used and will be used for really good causes. Secondly, you actually get to learn a lot about the electrical grid. So I don't come from an electrical engineering background, but in the past year I've learned like a lot and very technical stuff as well, just from mapping. And even for people who are very technical, you still learn quite a lot looking at satellite imagery and documentation and everything. And then thirdly, it's a bit more fun, but you learn about your country and other countries, geography, but also related to energy. You actually learn a lot about people, other countries' energy mixes. So, for example, if you're mapping and you see that a country has a lot of hydropower or solar panels, etc. So it's really interesting information to have. Fourthly, so this data, yes, it's being used by organizations and companies, etc., but it's open, so we should be able to use it ourselves. So basically, this data can be used by yourself, and we teach that as well, and how to extract this to, for example, here you can see a map that someone in our team has made who's from Zambia. Um, and yeah, so here you just extracted the power lines, the grid from Zambia, and had a population density map and managed to create this. So this data can be used by yourselves quite easily for different purposes and projects. Fifth, building a community. I think it's always nice to be part of a community. And 6 was actually quite fun. So like you can, if you're competitive like me and you want to be like your country's top power mapper or something, then you can do that, and it can be really engaging. So can be quite tough looking at looking for documents, trying to understand which line goes with which one. It can get really technical, but it can also be really, let's say, calm and chill. Like you can listen to a podcast and map some towers. So it's really for everyone. And just quickly on the sort of training that we can do. So we've got Starter Kit for ID or JOSM, which is basically what we're going through today. This is more for like really beginners. Then we have Pioneer mapping, which is looking more at using tools and strategies to map in terms of coverage. Then technical mapping, looking more, let's say, at the technical circuits, voltages of grids. Validation mapping, look at the quality of and validating the current grid data in OSM. Data extraction and processing, similar to what I just talked about how to extract this, how to use it, how to process it in useful ways, such as making maps. And then also linking OpenStreetMap data to Wikidata and using IDs, which is very useful. So quickly, I just went through the YouthMappers activity dashboard to see where some of you might be from and found a few hotspots. And here we've got, let's say, a few hotspots with the grid. So the grids are almost basically everywhere. And so I try to find as many good first lines and many things to map in every single country, which I'll be showing you a bit in a while. And so yeah, so before we start sort of the more mapping and the hands-on process, I'm inviting you to have any questions about the initiative, or yeah, the floor is yours.
There's someone asking about the capacity of the line in the chat. Andreas, do you want to answer this? Or?
Yes. So can we map okay, does it include other information? Yes. So no, it doesn't include the capacity of the power lines. It includes voltages, circuits, cables. But we are sort of basically developing a pipeline to be able to, outside of OpenStreetMap, in a way, use and put capacity data as well. Because, for example, for energy system modeling, this is the type of data that you would need. And for length, so technically on the editor, the length isn't on the line itself, but you can actually look at the length using the JOSM editor or one of our contributions monitoring. We actually can calculate length, for example, and even in our health score, one of the let's say, yeah, one of the health scores that we're doing is looking at comparing the coverage of official data in terms of length and the OSM data. This is really useful to see if, for example, there's a lot of lines missing in OSM or not. And so yeah, so that's one of the things with length. Can we map any power grid? Yes, you can map as long as it exists. Yes. Okay. We have more time for questions later as well. So I'm just going to start off quickly though. Oh, yes. Because I don't think everyone necessarily has, because I might be using words as a substation, which people won't necessarily understand. And I think it's really useful to understand how our electricity system works. And this will help you a lot with mapping as well. So just quickly here, there are kind of, let's say, 4 sections to this. So first, A is power plant. So this is where the electricity is generated. This can be hydropower, solar panels, wind farms, coal, gas. And this is generated in a certain area and it needs to be transported. And that is basically using, let's say, power lines, but at a high voltage, which is why we use transformers to reduce or increase the voltage in order to be able to transport as much power as possible for large distances with reducing losses. And so then you have the second section, let's say, which is the actual, let's say, grid, the power lines and the towers, which here is like number C, for example. and this will be most likely at a very high voltage or high voltage. And then this goes into a substation, which is similar to step B. Basically, it's a transformer. So basically, at the end of a line, you will have a substation where the voltage will be reduced. And then here you can see in this case, you can see two other towers, but who are smaller and who are at a lower voltage. Which then go into a distribution substation. So we can kind of classify our entire grid with transmission on one side and distribution. And here distribution then will go at very low voltages and go into, for example, homes. But this is an oversimplification, and we can go just quickly onto this, which looks a bit scary, but actually if you decompose it, it's the same thing. If you look at the top, you've got different plants, which is basically the same as power plants. So that's the generation, coal plant, nuclear, hydro, big solar farms and big wind farms, which then you can see the two little circles, that those represent basically like substations, which then goes into extra high voltage and high voltage. So that's the transmission system itself. What you will see though here is that some of the transmission lines are connected directly with large centers of demand. So for example, large industrial factories, so a large cement plant, for example, which themselves have their own substation and are connected to transmission grid. However, most of the transmission grid then goes into a distribution substation, and then that is, let's say, the beginning of the distribution grid at a lower voltage. So this thing basically goes to your residential areas, homes, customers, industrial customers, etc. What you find is interesting is also at the bottom right, you have solar farm and wind farm again. This is basically smaller, so distributed generation. So maybe you have a solar panel on your roof and it's connected to the grid, and it would be connected to the distribution grid. So yeah, that's just a little clarification. So I think this should give you more or less an overview of what we mean by the grid, the different aspects of it, generation, substation, towers, lines, etc. So now we can start mapping. If you map for this webinar, we've created a hashtag YouthPower, but you can also use our hashtag MapYourGrid. And we have our own website if you are interested, as well as a Discord channel and a YouTube channel. So now I'm going to start the starter kit tutorial, which, how do you do this? Okay. So first things first is to go to our website. So we've got a website with a bunch of information on our initiative, on the impact of the grid data, starter kit, strategies, etc. But for the starter kit, you just go to the starter kit page, and here you have different starter kits. So the ID one, which we're going through in just a moment. We have a JOSM one as well, if you're more comfortable with JOSM or have more experience, and also other ones with Map Complete, for example. We also have a video which you can follow. But yeah, so the first thing that you would most likely want to do is create an OpenStreetMap account if you don't have one. And if you do, then we can start basically the process. So the first thing you're going to do is go to our good first lines. So our good first lines, if you click there, basically is a page with just a bunch of, as we call them, good first lines, which are unfinished transmission lines, which are really good for beginners because we've basically put the coordinates and you can just go there and map the rest of the line quite easily, which I'll be showing you right now. And so we've got a bunch of good first lines, some easier, some harder for basically a bunch of countries. And I've tried to find a few lines for everyone if you're from these countries. So yeah, so this is what you would do. You would go to this page and then you would click on one of these issues. So for this webinar, I've prepared 3 good first lines. And so before mapping, for example, you can press an attempted mapping if you've attempted it or are attempting it. And if you haven't succeeded in finishing it, so that someone else with maybe more experience can map. This is also usable with JOSM, but I'm just going to focus on ID at the moment. So yeah, And then if you finish the line, then you can put completed line, and then this goes into an archive. So how would you map basically? So first you just click on ID Editor, and this is going to open a page with ID Editor, and it's going to move you to those exact coordinates of that good first line. So here we're in Bangladesh, and as you can see, we've got a power tower here and the line. So the imagery is actually really good. You can also switch. So on Bing, you can't actually see it, so it's probably a relatively new line. And you can also sort of, if you don't have these roads, etc., you can remove the data and just have the power features. So here, basically, I've been teleported to this good first line. And if you zoom out a little bit, you've got the tower here tagged as high voltage tower. You have other tags that you can put. And then the power line, which is tagged here with the operator, the voltage has been tagged, the cables. So the cables actually could be tagged here because you can actually see there's 6. So this is a type of metadata data that you can put on power lines. So in terms of how you would map this, so you have 2 ways. The first one is to just extend the line and try and find the next tower. So just a little hack, for example, is sometimes in this case, you can clearly see the gray metallic object, but many times, which I'll show later, the imagery might not be as good. So you might be able to find the shadow, but not the tower itself. But in this case, I can clearly see the next tower here, and it's a really, really good example of an easy, good first line. And so how you'd map this, I'm sure some of you know, but you extend it so you can use your keyboard and press A. That extends the line. Technically, you could also create a line from the node. But in this case, I'm just going to extend it. And so basically, all you need to do is just go like this and try and find the next towers. In most cases, they will follow the same direction. So in this case, I know it's going to go more or less this way. But from time to time, they obviously change direction. And as you can see, this line has been slightly mapped, but not the rest. So for example, you could connect it like this and then continue the line all the way like this. And so let's say you've mapped the line and finished it. And so the power line has already been tagged, but the nodes, the points that you've put, have not. So you could technically just click on a PowerPoint and then put high voltage tower, which is already here. So you would type that in. But in many cases, you might have 50 or even 200 towers on the line, and that's just going to take you for ages. So what you can do is use a keyboard shortcut, which is clicking on the power line, then do Control and down, which it should be in the help and keyboard shortcuts. And as you can see, it's selected all of the child nodes, so all of the nodes of this line here. And essentially, what you can do is tag all of these with high voltage tower. So most of these are already tagged. And since all of these are already the same type of tag, so they're all towers, you can safely just essentially tag. And as you can see here, it's tagged all of those points that weren't tagged. Now, just a warning is that sometimes if, for example, on this line you have something that isn't a high voltage tower, like a power switch or something, then you don't want to tag that as well as a high voltage tower. So you can just remove those specific ones and then just do what I did. So yeah, so that's a really easy way to map just really fast, like up to like, well, as many towers as you want. So that was one first example, but we can go through other ones just to, so you sort of see the type of imagery that you'll see. So this one is also quite good. You can switch. I mean, here it's under construction, but in Esri you can really see the tower. It's quite easy to see. This is, let's say, good quality imagery. Certain areas will not have this quality. And in this case, the tower has already been placed. So, for example, you could just continue the line like this, all the way like that, basically, and try and follow the line. So that's something that you can do. And then just quickly, if you're, for example, if you have, if there isn't a line and you don't know how to tag a line, and you're creating one, so like this, the way that you tag this line is just basically power line. One little thing, minor power lines are for distribution lines. So basically this one's a transmission line, and you can just tag it and then put, if you know the voltage, for example, it's very useful, cables, etc. So that's how you basically tag a power line. One last example, this time in Ghana. So here you can see a tower, not as clear, but it's still relatively clear. And the next one is here. So as we just did, Control A, A on your keyboard. The next one should be here, but let's say the difficulty is already a little bit higher because it's a bit harder to see, but your eyes will get trained basically if you map more. Here it's not going to go this way. It's going to change direction, and I believe it should end around here. So in this case, we've just mapped 3 lines, which we haven't necessarily finished. But as we saw in the explanation of the power grids at the beginning, lines basically finish at substations. So just for the webinar, I'm going to show you, for example, if you get to a substation, what do you do? So basically, so here I'm back in Bangladesh, and let's say you finish your good first line and you've arrived at the substation. So this is more or less what a substation looks like. Here it's a little bit clearer, and yeah, so that's what you'll get to normally. So let's say there are 2 ways to do this. If, let's say for beginners especially, or if the quality of the satellite imagery isn't very good, what you would do is extend it, and you could just place a node, and then this node you could basically map as a power portal or an anchor portal according to ID. And that's how you could basically connect the transmission line inside of the substation. So if the quality of, so if you know that the substation is there and you've mapped it, but you don't know exactly, but you can't really see, for example, the inside, then this is a very valid way to do it. But technically, if we want to be technical about this, then basically the way that you would do this is to, here is basically a portal. You can get a lot of information on the wiki, but here's basically 2 portals, and you know that this line has 6 cables, so it most probably has 2 circuits. And so the way that you do this is basically creating a line. First you create the power portal as a line instead of as a node, like this, and you try and get inside. It's well, a bit bad, but and then here you tag this line as an anchor portal, and then basically, since there are 2, one here and one here, it's not very easy to see, but the way that you do this is Control A, like that, and then here this little dot is technically it's easier to tag on GSM, but on ID you can also add a tag power equals insulator, because it's an insulator, and you'll see it's a power feature. And then you basically do the same thing with this basically portal here, and you tag this again as power equals insulator, and this is let's say more technical, so not necessarily for beginners, especially if the satellite imagery isn't very good, but this can actually be really useful information for more technical mappers, because it tells you that there are actually 2 circuits, which I can go into at the end of the video if you want, of the presentation. But yeah, so that's how to connect to a substation. But let's say that you've mapped and you've actually found a brand new substation that hasn't been mapped. And how do you map that? So let's go to Nepal, and I believe Esri, yeah, as you can see, so this is an unfinished transmission line, which could also be a good first line. And this should connect somewhere around here. And as you can see, this substation hasn't been mapped. So you can also look at the other types of data. So This is quite a new substation, and it's been mapped before as farmland, but technically this should be updated. But yeah, so how do you map this? Basically, you create an area and a delimitation around the substation like this, just like that. I'll zoom in a little bit. Try and be as precise as possible, but it's not the end of the world. If you do it a bit quickly, like I'm doing, more or less like that, let's just say. So you've basically mapped the area, but now you need to tag it. So the tag is basically substation, like that. If you know the name, it's quite useful information to have as well. The type, so it's mostly transmission, distribution, industrial generation. So in this case, I know it's a big substation and it links between transmission lines. So it's actually a transmission substation. You can put the operator, you can put the voltage if you know it. So that's basically how to map a substation. Another thing I'd like to say is that here you can see kind of a mess. And if you're not experienced, you kind of, I think there's a line here. Yeah, there is a line here. And it's kind of hard to see which one might go with which one. So what you can do is just simply Control C, copy the tower. And if you're uncomfortable with mapping lines, you can literally just map the towers. And that's absolutely fine as well, because then someone maybe with more experience can then realize, oh, actually this one goes with this one and that line, and then map it. So yeah, so basically don't be afraid to map. So that was how to map. And so just one thing on different types of substations, as we just saw, this one's a transmission one, but you might have the industrial ones. So basically here in I've got, I think it's a cement factory, yeah. And so since it requires a lot of power, it most likely has its own transmission substation, or basically industrial substation, which technically here should probably be a multi-polygon, but you can see a substation not very well, but here, and then this part as well. And if you look at the tag, then it should be, yeah, type industrial. So that's one type. Another type that you might run into is distribution ones, which are much smaller. So this one, for example, kind of hard to see, but here is basically a distribution substation. So some substations which are distribution will be linked to the transmission grid, and that's kind of like the substation that links, let's say, the two types of grid. And other distribution substations will just be distribution between different distribution substations, basically. And these will be quite small, but quite useful to map as well, even though it's not the transmission. But they might be harder to see since they're smaller. So yeah, so this one, yeah, regional distribution, as you can see here on type. So those were different types of substations. Now, another thing which is important as well, and you might run into, is if we just go to the Philippines, is here. You've got two lines which are power lines and not minor power lines, so they're transmission. However, the nodes, the towers, are tagged as power poles because they actually are poles. If you can go on to basically this page, which is well, the Power Networks page, the wiki for OSM has basically information on everything. If you have a question on, oh, is this a power tower, is this a pole, etc. So power poles can basically hold transmission lines, especially if they're close around cities, because in a city you might not have the space for a massive tower. So they basically make poles. So you might run into this, having poles with transmission lines. So the way that you would tag it is the same thing, except that you would basically just, instead of high voltage tower, it's power pole. And so another thing that I'd like to show, which is more kind of like a tool which you can use, is here is a substation. And here you've got two lines which connect to this one, but there's only one line here, and there's actually a power pole here, which is kind of bigger. Something that I've managed to find, something that you're allowed to use is mapillary imagery. And I found an example where it's really useful. And this can also sort of show you what I mean by power poles and power towers. But so I found this location in mapillary. And if you look at, sometimes you might have the imagery here, basically, on this pole here on the right is basically this side of the road. So this power pole here. And on the left, this line here is the one on the left side. And as you can see, these two lines connect with this power pole here, which has cables going to the left here and then cables that are attached to, let's say, this one here on the right. And then you can see that on the right side of the pole, you've got 1, 2, 3, 4, 5, 6, which adds up because you've got 3 incoming from the left and 3 incoming from, let's say, the bottom or the right. And then that connects to this this pole here with the 6 lines. So what we can basically see here is that this one here connects with this pole, which we saw, which had the 6 lines, which we can tag power pole. And so this is also a good example of showing that lines don't necessarily just follow a direct route. You might have lines connecting with other lines, as we just with other towers, sorry. So also don't be afraid if you see that, because it's not necessarily a mistake, but sometimes it can be. And so here, for example, you would have 2 lines connecting with the same pole. And a bit more technical, but some interesting information that you can put is that on here, you have 3 cables. On this line, you've got 3 cables. But on the line that's going to come out from this one, if you extend it, why can I not extend it? If you extend this one and connect it, this one, as you can see, has already been mapped, but it has 6 cables. So this is a type of actually more technical data, which is actually really useful and which you can sometimes use Mapillary to help you with. So yeah, so that was an example to show you what poles looks like, how different towers can have different lines going into the same node. Yeah. So then I've gone through quite a few examples of different power infrastructure. But let's say you don't want to rely on these good first lines, or your country, there aren't any good first lines for your country, and you want to find these using the ID editor or even JOSM. The way that you do this is go into our website, and we've got a Map It page, which basically has this interactive world map, which I was talking about, which is mostly made for JOSM, but it's also compatible with ID editor. The tools and hints are. And so the main tool that we can use here is Osmo's issues. And here you've got different issue types. So for example, if there's a power tower that's on its own, that's one of the issues that you can get. A very useful one, which we use, is unfinished power transmission lines, because this means that it needs to be finished and you can extend it. But there are many other more technical ones. For example, if there's a line which has 2 lines which have different voltages connecting with each other, then that might be an issue, which it can detect. So here, what you would do, for example, is you can click on a country, and that basically is going to, well, first, for example, if we go Cameroon, it's going to go up here and it's going to create a URL, which you can copy. And then this, thanks to the custom map data here, here, custom map data, you can actually put and paste the URL. And as you can see, all these pink dots are all of the Osmose issues for type class 2, so the unfinished ones for Cameroon. So here, basically, then what you could, for example, do is go manually on ID editor. It's not as fast, but you can manually go through each one and try and see if you can finish a line. So for example, if you zoom into this one, as you can see, this one is an unfinished transmission line. The tower isn't as clear, but it's a little gray here. Maybe with Bing, yeah, with Bing you can see it a little bit better. But so, for example, here what you could do is, as we did at the beginning, try and find the next one, which is here, like that. And the next one should be in the same direction, or not necessarily. Sometimes the imagery isn't good or updated. And sometimes you can go into cities, which can be really much more difficult to map. But in this case, for example, I managed to find an unfinished transmission line thanks to the Osmosis tool, which means that, let's say you've kind of gone past the good first lines and you want to find your own in your own country, then you can. But there are also other tools. So we have, for example, integrated here, Global Energy Monitor's power plants dataset. This one will actually download onto your device a GeoJSON. But basically, for example, if you can also, another thing I forgot to mention is that you can also use this for regions, specifically for big countries. It's very useful. So for the Global Energy Monitor, for example, if we go to India, this should download onto your device after a few seconds a GeoJSON, which then you can also use map data and basically go like that. And those are basically all of the power plants which are in the Global Energy Monitor's power plant database for that country or region country that you clicked on. So, for example, you can go through all these ones and check if they've been mapped in OSM. And you can also sometimes look at the data that it has. So sometimes people map a solar power, but they might not say which type of technology it is, so thermal or photovoltaic. So you can also do that for quality issues. So if we zoom into this one, or not, wait, which, I think this one wasn't mapped. Yeah. So here, for example, this one, as you can see, the custom map data gives me all the information which GEM has, Global Energy Monitor has, the capacity, the name, the start year, operation, state, if it's operating or not, the technology, etc. And so you can find power plants like this which haven't been mapped. This one basically hasn't been mapped. And so let's say you do this, and how do you map power plants? Similar to substations, you basically create an area and you just sort of do the delimitation of the solar power plant or whatever power plant you're mapping. I'm just doing it a bit quickly like that. Okay, so you've created the area, and now basically I already have it here, but you would basically do solar power plant or whatever you're mapping, so hydro, etc. Solar power plant. And here you can have all that information: name, operator, generation method. This is photovoltaic. The power output, the capacity. Oh, so for the question of the person at the beginning, we don't have capacity for lines because that varies, but we do have capacities for power plants, as well as start dates, etc. So if you have the information, you can add it. So yeah, so that was basically how to use Global Energy Monitor as a tool for the dataset, and also how to map power plants in OpenStreetMap using ID. Yeah, so basically that was the tutorial for ID. Other trainings that we basically give is Pioneer, which go through different strategies. And yeah, so this is about coverage, technical, etc. I am going to go quickly, I see we don't have that much time, but through the JOSM starter kit, just to show you that, let's say you've started mapping and you really enjoy it, but you want to be maybe a bit more efficient, a bit faster, and you want to be able to use different tools and strategies that we've built. So for JOSM, we have a starter kit which goes through, and a video which goes through all of the instructions to get set, using presets, using the remote control, etc. And even using our map CSS. But then this section is quite similar. So using the good first line, you can also basically go to that page. And similar here is using JOSM, and you can click there, which basically teleports you to that location. but it won't download all of the power data for that country, which is why we have the Map It page, which basically, if you use here, transmission over pass query, if you click on any country, so here's default, so anything above 50 kV, kilovolts, but you can also look at distribution, and you can click on your country or any country, and this is basically going to then connect with GeoSM using the remote control. And here I've already done that, but you might have to wait 30 seconds, 1 minute, 1 minute 30. Another thing is you can also use regions. So certain massive countries such as the US won't load just because there's just so much data, which is why we divided it into regions so it actually will work. And so here, for example, I've pressed on Bangladesh on this map, waited, I think, 40 seconds. And then here you've got a layer, and also the imagery is already loaded for you of all of the power grid data, which is an OpenStreetMap for Bangladesh. And so here you can see it's really more powerful to be mapping with JOSM just because you can actually see all of the grid. So it's really stupid, like simple strategies where this line clearly there's something wrong. It's not finished. The tower here, unfortunately, you can't see the next one. So that's probably because of the imagery. Yeah, definitely. And then many other things. You can, for example, filter for substations, doing power equals substation. And this is really good because then you can use things such as plugins and the to-do list, and you can go through every single substation really fast and look if there are any power lines which are new, which are going out from the substation. Because as we said, power lines go through in and out substations. So yeah, so we have tutorials for this. We can provide training for this. And we also have weekly on Wednesday, or bi-weekly on Wednesdays mapping sessions for anyone who has questions. We have a Discord channel for JOSM. And yeah, so there's just a bunch of different stuff that you can do, both in ID and Editor and JOSM. But yeah, I think I'll leave a few minutes for questions. And I'll stop sharing my screen for now. Sorry.
Fantastic work setting up all the tooling and workflows. Really great job. Definitely great webinar, learned a lot. But I was just wondering, you said you had bi-weekly sessions on the Wednesdays. Are those listed on OSM Where can we find those?
So we have recently put it on OSM the calendar, but it's also on our website. So I don't know if you have the link to the website. I'll just paste it in. But basically on our website, on the Map It page, the one with that interactive map, if you scroll down at the bottom, you basically have a calendar. We've just integrated a Google calendar, and there you can see all of the different sort of sessions that we do. Even, for example, today's webinar is on there. So I'll put that into the chat. Oh, well, okay, 50 chats.
I already did.
Okay, cool. Perfect. Yeah, so that's every 2 Wednesdays, basically. And yeah, what we basically do there is just sort of map easy stuff, complex stuff, if people have questions about certain things. And yeah.
Cheers. Thank you very much.
Make sure you go visit our YouthMappers 10-year anniversary webpage to explore our network's achievements over the past decade and learn how you can get involved in our celebrations. Our anniversary is on November 17th, so be sure to follow us on social media to stay up to date on all the exciting activities we have planned. On this page, you'll find dedicated sections highlighting all 3 of the mapping campaigns we're launching. For today's focus, visit the Where We Power the Future campaign page to access the webinar recording, to explore the starter kit, and to map your first line. Thank you all for joining, and happy mapping!